Section 9.5 is on hyperbolas. A hyperbola is the set of all points in a plane such that the absolute value of the differences of the distances from the foci is constant. That's pretty complicated. Let's just worry about how to draw one. The standard form of the equation of a hyperbola looks a lot like the standard form of the equation of an ellipse, but in this case, instead of a plus in the middle, this one has a minus. So it's the quantity x minus h squared over a squared minus y minus k, the quantity y minus k squared over b squared equals 1. The orientation of this hyperbola is going to be horizontal. That is, it opens to the left and the right, and the vertices lie on a horizontal line. You can also have a hyperbola that opens up and down, but we're not going to focus on that one in this video. The center of the hyperbola is the point h comma k, and it has foci at the points h plus or minus c comma k. It has vertices at h plus or minus a comma k, and covertices at h comma k plus or minus b, where c squared is equal to a squared plus b squared. And as we did with the ellipse, we're not going to really worry too much about the foci, and we're going to get the vertices and the covertices when we graph it. The length of the transverse axis, and that is a segment between the vertices, is going to be 2 times a, and for this one that's going to be the one in the horizontal direction. The length of the conjugate axis, which is the segment between the covertices, which is going to be a vertical line, the length of that is 2b, and a hyperbola has asymptotes. It has diagonal lines that the curve approaches but never touches, and it's given by this equation here. We're going to draw the asymptotes, but I'm not going to ask you to give me their equations. So let's try a couple examples here. So for each hyperbola, write the equation in standard form if necessary. Identify the center, the lengths of the transverse and conjugate axes, and the coordinates of the vertices and covertices, and then graph. Well, we're lucky this one is already in standard form. So as we did with the ellipse, we're just going to identify some of the values here. So my h is 3, my k is -2, my a is 5, and my b is a +2. So remember, it's x minus h, so that gives me 3, y minus k, so y minus a -2 is y plus 2. A is the square root of the number underneath x. B is the square root of the number under y. So my center is going to be the point 3, -2. And I'm going to go ahead and graph that. So the point 3, -2 is my center. Now, we're going to do as we did with the ellipse. We're going to use A to go that many units right and left. So I'll go 5 units right and left, and that's going to be my transverse axis, okay? And then I'll use my B to go up and down that many units, and that's going to be my conjugate axis. Now, if this were an ellipse, I would just connect those points and make a curve. But a hyperbola, if you remember from the first screen, it kind of goes out like almost like two little parabolas, one going opening to the right and one opening to the left. To do that, I need to create the asymptotes, but before that, I'm going to draw a box, basically a rectangle, that connects all of these points. So my rectangle looks something like this, okay? And it's going to include those vertices and covertices. And now I need to draw diagonals in that box. So I need to draw the diagonals of the rectangle and extend them out beyond. Those aren't super straight, but you get the idea. And these are going to be my asymptotes. And as I said before, we're not really going to worry about what their equation is. I just want you to draw them. Now, to draw the hyperbola, it's going to go from my vertex, from each of my vertices here at the ends of the transverse axis, go from there and out towards the asymptotes like that. So there's one piece of it, and then the other piece goes like this. And remember, with an asymptote, the curve approaches the line but never touches it. So all that's really a part of the hyperbola here are the two black curves that I drew. The the pink dots, the pink rectangle, the pink diagonals, the asymptotes are not a part of a hyperbola, but you should really draw those in order to help you to draw the hyperbola itself. So let's identify a few things here. So I need the coordinates of the vertices. The vertices are these points right here. So that's going to be 3, 4, 5, 6, 7, 8, -2, and -2, -2. My covertices are the ones that are going to be up and down. So that's 3, 0, and 3, -4. The length of my transverse axis is 2 times A, and that would be this line right here, going between the vertices. That's 10 units long. And the length of my conjugate axis, that's the vertical line between the covertices. It's going to be 2 times B, or 4 units long. So graphing a hyperbola starts out a lot like graphing an ellipse, because you have to find your H, K, A, and B, and you do your dots, 5 dots. But from there you have to do the rectangle, the diagonals, and then draw the curve. Let's try one more example. Here I have 16x squared minus 9y squared plus 128x plus 36y plus 76 equals 0. This is obviously not in standard form, so we need to put it into that. So as I did with the ellipse, I'm going to rewrite it with my x's grouped together and my y's grouped together. Notice what's different here is there's a negative in front of your y squared. That's what makes it a hyperbola. And then I'll move my 76 to the other side. Okay, now I have to do the completing the square thing, so I have to get rid of that 16. And 128 divided by 16, I believe, is 8. Okay, and take out the -9. And this is a little tricky, so you're going to be factoring out a -9 from 36. So that's going to leave you with a -4y. And now let's complete the square. So half of b squared is 16, but I didn't add just 16. I really added 16 times the 16 out front, which is 256. And half of b squared here is going to be 4, but I didn't really add 4. I really subtracted 36. So I have to subtract 36 over here. So let's factor our trinomials. Okay. And I believe all of this over here adds up to 144. And as with the equation of an ellipse, the equation of a hyperbola has to equal 1. So I'll divide everything by 144. And this one's kind of neat and tidy as well, because 16 times 9 is 144. So that's going to give me x plus 4 squared over 9 minus y minus 2 squared over 16 equals 1. And there's the standard form for my hyperbola. So before we graph it, let's identify our h, k, a, and b. H is -4, K is 2, A is 3, and B is 4. And now we have enough information to graph it. So my center is going to be at the point -4, 2. So I will graph that. -4, 2. My A is how many units I go left and right. Okay, those are also going to be my vertices. Maybe I'll go ahead and write those now. So my vertices are -1, 2, and what is that, -7, 2. Okay, and that's going to be my transverse axis. The length of my transverse axis is 6 units. Okay, now let's use our B. So from the center, I'll go up 4, and I'll go down 4, and those are my covertices. So maybe I'll go ahead and write those out now. So that's negative 4, 6. And negative 4, 2, negative 2. That's my conjugate axis, and its length is 8 units. Now I need to draw the parabola. Remember to do that, I'm going to draw the rectangle that contains the vertices and the co-vertices. Okay, and now I need to draw the diagonals, which are going to be my asymptotes. Okay, and now that I have my asymptotes, I can actually draw the parabola. The vertices are going to be on the horizontal transverse axis. They'll actually start there and swoop out towards the asymptotes. And there's your hyperbola. Remember, the only thing that's actually the hyperbola are the black lines. The pink lines are all just to help you to draw it. So to review a little bit, we looked at a parabola, and we saw that the standard form of its equation is very similar to that of an ellipse, except it has a minus in the middle. In this video, we focused just on those that have a horizontal orientation. And as we did with the ellipse, we identified HK, A, and B. And we used the HK was our center. We used A to identify our vertices, B to identify our co-vertices. But from there, we drew a rectangle. We drew the diagonals, which are the asymptotes, and then the curve is within those asymptotes to the left and to the right.